online. Okay, so for today, I'm going to go through some super basic stuff because again, 100 level class. So we're going to go through the syllabus. We're going to talk about how we're going to structure this class. It's not going to be structured the way that it's in your class portal, okay? Which, thank goodness, we only have to be awake at 8 a.m. twice a week. Okay, we can have a party later because of that. We're going to do an introduction into GitHub. Does anybody know what GitHub is? Have you heard of it? Worked with it? Okay, cool. That's a lot more yeses than I thought. I mean, I got you. There's a few no's. I get that too. So we're going to go through GitHub, what it is, why we're using it, why you need to know how to use it. And then we're just going to do a little bit of a C introduction. And again, super high level. After today, you should be able to do the first homework assignment and the first lab. First homework assignment is literally to create a GitHub account. Come on, if you already have a GitHub account, just send me your username so I can connect it to the classroom. Okay, for those that have used GitHub. Okay, homework 1, done, check. Okay, lab 1 is to go through the introduction on GitHub. So really, it's just updating some of your README, for those that know what that is, and your personal little profile on GitHub. Okay, super easy. Do it on any machine, doesn't matter. Okay, because the introduction we're going to do is more background and what it is. Wednesday, we will get into actually writing our first program and looking at it and going through some of those steps. Okay. And usually what I like to do is I like to tell you guys at the beginning of class what we're going to do. Then we'll walk through it. And then at the end of class, I kind of wrap up what we did for that day and then kind of tell you guys what we're going to do next time. Okay. Just to kind of give you how I function. If you had me for GT 103, this is going to be completely different, y'all. Okay, completely different. Okay, just so everyone knows. So first up, syllabus. I apologize. It got posted late last night. There was a last minute change in instructor for this class, so I apologize. It's still not 100% when it comes to the assignment section. Most of the other sections, though, are pretty complete. Okay, this is the book that we're using, How to Program. 9th edition. If you get your hands on an 8, that's fine. Don't care. Most part. 9 is pretty new, so it's probably the more expensive one. Go ahead and order an 8. I have a copy in my office. If you would like to come to my office and look at it or whatever, that's fine. Easiest, fastest way, ebook. If you're not an ebook person, I'm not. I get that. I will pull up the syllabus here in a second. The other thing in the syllabus, well, I'll just go ahead and move it. I change my mind all the time, it's fine. Let's see. I have so many windows open. Okay, so the syllabus at the very top, my information, where to find me. I am in Stevens 107. Stevens is the next building over that kind of has dorms in it. Right across from Tech, kind of in the corner, that's where my office is. Usually on my door, it says whether I am on campus or off campus. If I'm on campus and not in my office, y'all know where I usually am. I'm usually in the labs down in Poe. Okay. You see me down in the labs, come on in. I'm probably installing something on the machines or something. Okay. That's what I'm going to be doing this afternoon. Just ready for this week. Okay. So if I'm not in my office, other person you can ask, and don't tell her I said this, you can ask Taylor upstairs if she knows if I'm on campus, because we carpool in, so she'll know if I'm here. Don't tell her I said that. My email address and my office hours. So once we figure out once I explain to you how we're going to structure this, I'll figure out what my office hours are going to be. It's probably going to be like Monday afternoon. And then when you can get a hold of it. Okay. There is a link up there. Please use that link. That link is linked directly to my personal calendar. And if I'm going to be off campus or someplace else, or I have another appointment, it is all wrapped into that Calendly link right here. Okay. There we go. This Calendly link. Okay. Easiest way to get a hold of me. Okay. We will have an appointment. It'll give me a set time. You'll have that time reserved. Okay. My email address, and then I have a Discord. Okay. Do you guys know what Discord is? Okay. So does anybody not know what Discord is? No? Okay. Well, I have a Discord channel. You don't know if Nathan doesn't know what Discord is? I know Nathan's on my Discord, so I know he does. Oh, are they?
to Discord at the very bottom.
Oh, I didn't know that.
Yeah, it's.
Okay.
been on for like a couple weeks.
Okay. Well, I did put this up as a permanent link, so if you want to keep trying to click on it. I did create a channel specifically for this class. Okay. Use it, ask questions, answer questions if you have the answers. Okay. This is a collaborative environment when it comes to programming, because I'll tell you what, I programmed out in the real world. I don't, you know what I mean, right? No, it's not like real world, but out in the real world for over 20 years. You're never alone. Okay. There's always someone that's asking questions, and there's always someone to ask a question of. Okay. So if for some reason you can't get something to work later on down the road, post a question in Discord. Okay. Discord will also be the fastest way for me to answer. Okay. You can send me a direct message in Discord. I have Discord on my phone. Okay. If you need an answer like within 24 hours, use Discord. If it can take a day or two, email. Does that make sense? Okay. And again, reach out to your fellow classmates. You know, oh, I forgot, how do you make a comment? I'm sure someone could chime in before I even get there. Okay. So please use the Discord and join that channel. A little bit about course delivery methods. We're going to talk about that in a minute. There's our book. We already did that. Okay, resources. So we are going to need a resource that's going to allow you to create a flow chart. Okay, Word does it just fine. Okay, it's a little clunky, but you can do it with Word if you would like. We're going to use a program called Flowgorithm. It is free. Okay, the biggest issue is it only runs on Windows. Okay, there's not a Mac version of it. So that's what we're going to use in the lab. Visio, if you have access to a Visio license, they do pretty good with flowcharts. Lucidchart is going to be the one if you have a Mac and a laptop and you want to use that. Okay, it's an online cloud web-based. You can just do a free trial, it'll be fine. And you can put your flowcharts into Lucidchart. You can try all of them. Visio, you need a license. Microsoft Word, you need a license, but you do have a license through your Carolina University email using Microsoft 365. Okay, so, and then Lucid and Flowgorithm are free. Now, C compilers. So we're going to do a program, and we're going to get into a little bit in a minute, that we need compilers to translate it from what we tell it to what the computer understands. Okay, there's a few, there's more than a few out there, you guys. There's hundreds of them. Okay, some of the better ones, Eclipse. I don't know if anyone heard of Eclipse. Eclipse will run Java, C, it'll compile several different languages. Dev C++ we have in the lab. Fairly easy one. Okay, just make sure you rename yours as a C program, not C++. Visual Studio, that's what we're going to use in class in the labs. Okay, if you do the community version, it's free. And it connects really well with GitHub. Okay. If you have a Mac, Xcode, it's an app store. You can download that app. And last but not least, we are going to be working on some Unix virtual machines in the lab. So get a feel of how to do it with command line and not really using an IDE. So we are going to be using the GCC when we start going into our Unix versions. Okay. Again, most of those are free. Actually, I think all of those are free. I think all of those are free. Click, again, it's a preference, or you will be told by your employer what you're going to use. Just gonna let you know. Okay. They all pretty much do the same thing. Okay. Again, once we lay this foundation, it's just going to be a matter of where do I find the compile button? Where is the runtime environment? How do I tell it to run from a command line and not a GUI? Okay, it's just kind of logistics of where things are, but they're all beautiful. Okay, you can read through some of those. So homework and participation, again, that's going to be your attendance in the homework assignment. Labs, so there's going to be at least a homework and one lab per week. Okay, that's what I haven't quite looked at all the way down through the end of the session. Okay, each lab it may have multiple parts, like the first lab is gonna have one part because it's that GitHub lab. Lab number 2, which is gonna be for this week as well, I think has 3 different parts. Okay, most of the times part B is gonna build on part A. Okay, so for this, I think part A is like print something to the screen, and then part B is like do a calculation and then print it to the screen. You know how that works? And then part C is make a decision, make a calculation, and then print it to the screen. Okay, so they're gonna build on each other. So it's not 3 separate labs, right? It's kind of 3 parts. There is a final project. Okay, we are gonna be doing them in groups. And I'm not gonna say much more than that until the midterm. Okay, because y'all get it in your head and you wanna go crazy on it. Okay, we're not even gonna tackle that until the midterm exam. So there's a midterm and a final. Okay, midterm is gonna be the first, I think, 6 chapters, 5 chapters, chapters 1 through 5. The final is 6 through 11. The final is not cumulative. Okay, so we're gonna do the first half, which is all those basics. We're gonna have our midterm exam on that. Then we're gonna start getting into some of that intermediate and fancy stuff, okay? That's where your project's gonna come in, and then that's what the final is gonna be, okay? Now, that being said, in the final exam, you have to know stuff in those first 5 chapters in order to answer the questions from the chapters from 6 to 11, you see what I'm saying? Okay? You guys may have taken other exams where it's like, okay, chapters 1 through 3, and then you kind of forget about that and then move on to 4, 5, 6. Programming is not like that. It's all building blocks. Okay. I will be doing the exams in here. Okay, it will be during class time, or we'll figure out where to do it. Because that gets us away from having to use Proctor Free. My nemesis, right? Who likes Proctor Free? Thank you. Okay. So it gets us away from using Proctor Free. And I will allow you guys to do it with paper and pencil if you would like. I prefer paper and pencil because I can see your logic better than just answering a single question. So we'll talk about more about that when it gets closer to that exam, okay? So this is the part that's still a little wonky, okay? So today, introduction, I've got the first 2-3 weeks pretty good, okay? Next Monday is a holiday. Okay, I'm not gonna be here. It's MLK Day, Martin Luther King Jr. Day. So I'm not having class that day, okay? If you have other classes on Monday, please check with that professor. Okay, just so everyone knows. I'm not holding class on Monday, okay? As you can see, we're gonna have 2 lectures a week. Okay, we'll talk about the other 2 days. Okay. So lectures are gonna be Monday, Wednesday. So you can see I've got us kind of to the midterm, and then it kind of, I'll finish that hopefully this week. Okay. And I believe the rest of this, oh, that's right, the rubric. 4 programming classes, okay, and I'm hoping other professors will be using this. We have a standard rubric that we're going to use when it comes to any time you hand in a program, okay? That way, you know, every single time you hand it in, what's being expected of you, okay? So in this table, it shows what class learning outcome on the very first column, and then you probably ignore that one, okay? Then it goes into criteria, sub-criteria, what you need to do to get an A, which is 100%, a B, 85, C, D, F. Okay, it spelled it out right there. Okay. Let's see. There's one I'm specifically looking for, and I pointed out because it's the one that everyone always forgets. Let's see. There we go. Criteria: ability to produce a readable program, commenting, and descriptions. Okay, this is the one everyone's gonna lose points on, I'm telling you. Okay, for an A, it is well documented and clearly explains what you're doing. Okay, it's worth 8 points. Okay, documentation is simple, comments, and the header, yeah, you're okay. Okay, documentation is simple, you've got a header, and that's about it. Okay, barely any comments, no comments. Okay, I can't stress to you how important commenting is. Okay. If I ask you, well, maybe because you all are young, but it's fine. If I asked you what you had for dinner like 3 Tuesdays ago, maybe on a Tuesday 3 months ago, will you remember? No. I can tell you, I picked up my own code months later, 6 months later, and thought to myself, what in the world were you thinking when you did this? Because I'm sitting there going, I didn't write this. There's no way I wrote this. Okay. You know, because you picked up other people's stuff too. Okay. That's me looking at my own stuff. Okay. If I have to pick up someone else's, update, correct, expand, right? It makes it very difficult if there's no comments in there to understand what's going on. Okay. So that's a big one. So take a minute, get used to this rubric. Every time we write a program, we're going to be using this. Okay, it tells you explicitly right there what I'm looking for. Course grading, assignments. I think that's pretty much all for the syllabus. Questions on the syllabus? It's all pretty standard, normal. Okay, let's go back to the PowerPoint. So, class structure. What I'm trying to do is we will have our Monday, Wednesday lecture, our 8 a.m. right in here, hour and a half-ish. Okay. What I'm doing with the Tuesday, Thursday, we're gonna have a lab. Okay. You're gonna be required 1 a week. It's gonna be a 3-hour block, which is a double class. Does that make sense? That's where those other 2 days are going. They're going to be down in Pope 202. It's on the western side. It's not the blue one, it's the one across the hall. And there is a specific Calendly link for signups in the course information portal. Okay. Right now, we have a lot less people in here than what they had told me originally, so we might be better off getting away with not having so many labs. But right now, we've got one scheduled for Wednesday afternoon at like 1 o'clock. Thursday morning at 9 a.m., Thursday afternoon at 1 o'clock, and then Friday at 1 after chapel and lunch. Okay. Our issue with this is we can only fit 8 in that lab. Okay. If you have your laptop, you do have 2 extra desks in there. Okay. So I can fit up to 10 if 2 people want to work off their laptop instead of one of the folks. Okay. It might turn into an issue when we start working on the Linux virtual machines. You might want to just go ahead and use the ones in the lab. Might be a little bit easier depending on how much memory and hard drive and all that good stuff you got. But take a look and sign up on the Calendly link and see when you want to come into lab, okay? As of right now, I will definitely be there for the Wednesday and most likely the Friday. The Thursday, I'm trying to get some help to cover. If not, I will be there. Cool? Everyone understand that? So please do not wake up at 8 a.m. tomorrow. Like I should wake up at 7:30 to get here at least, right? Okay. I won't be here tomorrow. Sound good? Okay. Any questions about that structure? No? Okay. If for some reason you cannot fit any one of those available lab times into your schedule, please let me know. Okay. Because I know like with basketball, I'm not sure. And work and volleyball, and you guys are actually like in season and stuff. Okay. So if for some reason you're having a conflict and you just cannot make any one of them, let me know. We'll figure it out. Okay. Okay. Next, we're going to do an intro into Git and GitHub. Okay. I know there were a few people that said they had used it. There were many that said they had not. So first, we're going to talk about Git. So Git is a version control system, okay? And what its job is to help multiple people either work on the same thing or to be able to have a better version control, okay? So sometimes across multiple platforms or multiple developers or teams for this class and for our purposes, it's going to be you and me, okay? It allows you to see changes easily. And it keeps track of those changes. And it allows everybody to see these changes. Okay. Git and GitHub are different. They are not the same thing. Okay, so what's GitHub? GitHub is a website that hosts those Git repositories. Okay, so really all it is it's your way to access those Git. GitHub.com. Okay, super easy. Sign up, free. No big deal. Okay. It facilitates that sharing of code between developers or teams by using a nice little interactive GUI, friendly, pretty looking thing. Okay. You can do something called a fork, which means you basically freeze it at one point and create a copy of it to make changes. So it kind of looks like a fork in the road. Okay. Or you can clone, which is what we're going to do mostly in this class. Okay. I will clone your assignment on my machine so I can see exactly what you did. So I can grade it. Okay. What you're going to do is you're going to push your changes up to the GitHub repository. And it's also going to help you create a developer profile or portfolio. Sorry, portfolio. Okay. It's going to keep all of your legacy code that you've done up to that point in one place. And you're going to be able to go back to it anytime. Okay. So GitHub runs on Windows and Linux. I believe it works on Apple-ish. You know, Apple. Does anyone have a Mac in here? Or YouTube? I knew you did, Nathan. It is going to be installed on the lab computers. The desktop version is going to be installed on the lab computers. Okay, there's a desktop version you can also do by hand. Okay, link in e-learning if you want to install it on your personal machine. Okay, so change tracking. Git and GitHub allow you to connect comments to changes. Okay, that will be held separately. So if you say updating for Professor G's comments, update my homework, you put that as a comment. So when you go back and go, why did I make that change? It'll tell you exactly why. And it doesn't have to be in the code. Okay. You can also use this branching. And this is where I said you can make that fork. Okay. So if you want to keep it the same and try out a new function, make a fork. Okay. One will continue on the path. The fork may have the new function. You can have them come back if the function works. If that function doesn't work, you just ignore it and that fork goes nowhere. Okay. You don't use it. Okay. Keeps your code safe. Okay. So when you get it and it works, it's safe. Okay. Easy collaboration on projects. So here, Mr. Yellow has made some changes and added 2 new files. Okay. Mr. Red over here comes in later. How's he going to know what changes were made by Yellow? Okay. Well, if Yellow pushes his changes and the new documents up to the GitHub, Red can then pull down those changes and the new files. So everybody's working off of the same thing. Okay. It'd be important, especially when you get to that project and you're working in partners or teams. Okay. What's going to happen if Red starts making changes on something that Yellow already changed? You're duplicating work, right? Number one, which who wants to do that? And something Red does may not mesh well with what Yellow does. Okay. So everybody has to be on the same page. This looks a little elementary when we're standing in a classroom and we're talking about, a single file or, 20, 30 lines of code. I've worked on code before, which were like hundreds of files with hundreds of lines per file. You can't tell me go to file number 3, go to line 876 and make this one change. That ain't gonna happen, right? When you do the pull, you automatically get everybody's changes. You've got multiple people working on it, okay? Especially we're going to be using GitHub Classroom. All that's doing is it is giving me a way to distribute an assignment, okay? It's going to create a Git repository with some initial files in there. And that's how you're going to get started, okay? For the first half, for the most part, you're just going to be creating new files and putting them up in Git. For the second part of the class after the midterm, we're going to be looking into debugging. Okay. will be some files up there that intentionally are broken that I'm gonna expect you to fix and push it back up. Okay? Easiest way for me to do that, especially with our lovely e-learning system that doesn't allow you to upload all kinds of file extensions, we're just gonna stick to GitHub. Make sense? Okay. Git and GitHub are used very, very frequently in the industry. Okay, there's even a GitHub platform for our book. Okay, that's all in the links for the first week. Okay, he's got all of the example problems out of the book in a GitHub repository that anybody can go look at any time because they can be public or private. Okay, so it is something that's used out there. Okay, might as well start using it now, getting comfortable with it now while we're all learning, right? And when you have your first job, they're like, hey, go push this. And you're going, huh? Right? So now's the time to learn and ask questions. The desktop, the Windows version, your files are going to have your name and email attached. Okay? Make sure you log in, if possible, using your Carolina U email. Okay? Would help me. What's up, Amy? Not today. I'm sure I have at one point. Wasn't me. Okay. If you sell it, file option, sign in. It'll automatically push you an email out there every time you don't have to worry about it. Okay. I did put first homework walkthrough GitHub, sending in your username so I can connect it to the classroom. Already kind of talked about that. Any questions about the Git and the GitHub? There is a journal article up on the e-learning. It does talk about one of these. There we go. There we go. So if I go to weekly course overview, this, excuse me, do you have a moment to talk about version control? They really go into using Git and GitHub, and I got some of those pictures from there. Okay, take a moment to read it. Now they use our programming language, but in different programming language, it doesn't matter. The basics are the same. Okay, so take a minute and read that for a little overview. Any questions about the Git and the GitHub? Yes.
Not too much. That are just slides to get open source.
I haven't decided yet. I know why. Have not. He asked if those slides are going to be available, and I really haven't decided yet. Okay. So any no questions, comments, concerns on Git and GitHub stuff? Okay. Let's look at. I'm just trying to check it. I'm really bad at this. Okay. So let's look a little bit into programming languages, computers, and where we're going with this. Okay. So, forgot to click on my screen. Hold, please. Please play your own hold music. There we go. Introduction. Okay. So, I've said some of this before when I was doing the little kind of caption. C is one of the world's most senior programming languages, but it is also one of the world's popular. Okay. You're probably familiar with a lot of the tasks that we're going to be able to do. You're going to be surprised by what few amount of tasks a computer can actually do. It's just how the programmer manipulates those to do what it needs to do. Okay. Software controls the hardware. Your hardware is the things you can touch. Okay. Anything you can touch, that's your hardware. How it's controlled is written by software in any way, shape, or form. Okay. Otherwise, it's just gonna sit there. Widely used in industry, today's popular desktop operating systems, we talked about this, right? Windows uses it. Unix was based on it. Okay. A lot of popular applications. Chrome, Firefox, database management systems. They were all written using C. Okay, so you can see where this is going to be important. Okay. We're also going to discuss some different types of languages. We're going to talk about the C standard library. Okay. This is going to help us to not reinvent the wheel, with how they call reinvent the wheel, which means we're not going to do something that someone's already done. Okay, we're just gonna use what they did. Right? We're not gonna do it again. We're also gonna look at some other technologies and stuff that we can use, okay? So again, these are the development environments we talked about a little bit in that syllabus, okay? Microsoft Visual Studio, Community Edition, there's Clang, there's Xcode, the GCC for Unix. Okay, I'm sure if you Google C compiler, you'll get a list. Okay, you'll see some of these and then you'll get another list. So hardware and software. Hardware, again, that's what you can touch, that's what you can see. Sometimes you can smell in the best, do that in the bath, right? Your computer that ever started like making a weird smell? Only me? Okay, rock on. Okay, so computers can perform calculations and make logical decisions for a human. Why? Because they can do 1 billion calculations in the time that it takes us to even think about the question, right? Supercomputers can do thousands of trillions of instructions per second. Okay, I can't even comprehend that. Okay, computers process data using what they call control sequences. Okay, a computer, when it comes to control, can only do 3 things. Okay, it can step forward sequentially and do the next step. That's number 1. It can make a decision. Okay. If the door is open, walk through it. If not, open the door. Okay. Or it can do repetition. That's it. So it can do the same thing over and over again. It's how you put those 3 building blocks together and put them one inside of another and things like that. That's how you're going to get your computer to do what you need it to do. Okay. So computer programmers are going to use these components to give instructions to the hardware. Okay. So my physical devices, there we go. Regardless of the physical device differences, all computers in the end act the same. Okay. So they can go into different logical units. Okay. Everybody can do the same thing. Everybody does it just a little differently. Okay. We've got an input and an output. Okay. You tell the computer to do something, you give it instructions, it has something that comes in, it does something, and then it spits it out. Okay. Regardless of the hardware, regardless of the manufacturer, it does those 2 basic general things. Okay. You receive data or you send data. Okay. There's some manipulation in the middle. Okay. Each computer has a memory unit, right? We've all heard of RAM. How much memory is in there? What does that mean? Okay. Rapid access. It's a warehouse where your information is going to be stored for runtime that's easily accessible and it's fast. Okay. You have to keep putting things on the hard drive. It takes time to go out to the hard drive and find it and then run it from there, right? So when you put it into memory, it just goes into memory and it's able to run it. Okay. The biggest thing, memory is volatile. That is a word that you're going to need to understand. Does anyone know what that one means? When you turn that machine off, it is gone. Okay. Anything that is in your memory, when you turn your machine off, it disappears. It is not long-term storage. It's definitely short-term. Okay. Only while the machine is on. Okay. Next time you start up the machine, it will put more things back into that memory to run again. But for the most part, anything that's in the memory only is gone when that machine is off. Okay. We call it memory, primary memory, random access memory, or RAM. That's what the RAM stands for. I don't know, there's a random G there, just ignore that. How do computers get information? How do they talk? What's their language? Do you guys know? Binary. You know why? Because electricity is either on or off. That's all I got. Right? So if you're thinking about it, it's a light switch, on, off, binary. Okay. Everyone seen those 1s and 0s? That's all you got. 1s and 0s. A whole lot of them. Okay. We're gonna go into binary very little this class. Networking, a lot more. Okay. Oh, that's where the G goes. Look, check it out. Online. Gigabyte. I mean, now we do terabyte, but gigabyte is approximately 1 billion bytes. Okay. A byte is 8 of those binary bits. Okay. So a bit is a 1 and a 0. Binary, a byte is 8 of them. Keep the 8 together. Okay. Every computer is going to have an ALU and a CPU. ALU, arithmetic logic unit. Okay. That is the section that's going to do these calculations. It's going to perform something. It's going to do something, right? Do something. Make decisions, compare things. Technically, it's a part of the CPU, but it has a special designation. Okay. The CPU, on the other hand, that's what we basically call the brain. Okay. We know it's not, it's an inanimate object, right? It's not actually a thing. We do compare, though, the CPU to a human brain. Okay. That's your administrative section. That is going to be your coordinator. That is going to do the supervision. That is going to do everything else to make sure everything gets done. Okay. Tells the input when to read. Tells the output when and where to print. Okay. Because where could you output to? Screen, printer, speaker, right? How do we know which one to output it to? Your CPU is going to do that. Okay. And it's also going to communicate with that memory and tell the computer when to put things in memory, when to retrieve things from memory. Okay, and when to do that interaction. Okay, how to get input. Okay, your CPU is going to make that determination because what you can do a mouse, keyboard, you can do a touch screen, you do a scanner, right? You can do a mic, you can do all these different types of input. Okay, CPU is going to be the one doing all of that coordination of who's doing what. Okay. Now, we have several different levels of what we call languages. Okay. So, any computer can directly understand its own machine language. Okay. Machine language is hardware dependent. Okay. So, if I have an Acer versus a Dell versus an HP, they may speak different machine languages. Okay. This machine language is what? Ones and zeros, right? It's that binary. Okay. Now, there's my ones and zeros. So I'm getting ahead of myself. We're cool. Everything's great. Machine dependent, particular machine language. Look at me. I'm like so far ahead of myself. Can you read machine language? I don't want to try. Have you ever seen those ones and zeros? I'm not trying that. Okay. So in a nice way, it's cumbersome for humans to understand. Okay. It's hard. Okay. So what we have is if we were to take the machine language and attempt to program it, it's going to be slow and it's going to be cumbersome for a human, right? It is hardware dependent. So if I want to just take something and print it to the screen, I'm going to have to write one program for an HP, one for a Dell, one for an Acer, one for every manufacturer out there. That sounds horrific to me. Okay, so instead of using that binary, what we do is we use something called the higher level languages. Okay, as you get higher in the level of the language, it gets closer to how a human speaks. Okay, lower levels closer to the computer, higher levels closer to the human. Okay, so we're going to use English-like. Okay, so some of the words are going to make sense to represent some of those elementary operations. If we want to, we're going to find out on Wednesday, if we want to print something to the screen, we say print. Imagine that, right? That's a whole lot easier than trying to remember the zeros and ones for your specific machine, what it's going to do. Okay. That's going to form the basis of how we communicate with those machines. Now, between that high level and that machine language, there is an assembly language. You may have heard people that program in assembly. It's kind of a mishmash. You're not quite in human terms, but you're definitely not in binary. You're kind of somewhere in the middle. Not something you can pick up and read. Okay. got a lot of things that don't make sense, but it's called assembly. It's kind of in the middle. Okay. What we are going to do is we're going to use something to convert our English type words into that binary. Okay. And what it's going to do is it's going to convert it into machine languages so fast, we're not even going to realize it. Okay. So typical high level language, we already talked about that. Translator programs. So there's a difference between a translated program and a compiled program. Okay. Python is a translated program. C is a compiled program. They're different. Okay. Python, typically you can type in a command and run it line by line as you type. Okay. In a compiled program, you need to write the entire program, compile everything, and then run. Okay, so it's a little slightly different. Okay. Again, our high level language, we're getting closer to English every day. Okay. And we can have our, the other good one, we use our common mathematical expressions, okay? If I want to say A plus B, I do A plus B. Okay, I know what that means. C is among the world's most widely used. We already do that. Okay. So sometimes compiling can take a lot of time, depending upon how much code you're using. Remember, I said I was using hundreds of files and hundreds of lines per file. That took a long time to compile. We used to compile it before we left for the evening and hoped it was finished by the time we got back the next day. And if there was an error, that was just hard knocks, right? Okay. Interpreters are going to execute those directly. Okay, that's that translation. Okay. So if you use an interpreted language using those translators like Python, they are a little bit faster. Okay. But they're not, because they're not going to run as a chunk. But every single time you run something like Python, you run it line by line every single time. In a compiled program, you compile once and run it 1,000 times. It never has to compile again. Okay, so you need to see what's better for your use. Make sense? Okay. So some languages like Java and Python have some kind of mixture of the two. So let's talk about C. So C actually evolved from two earlier languages. And this was back in the 70s. This was before I was born. Okay. So it was developed in Bell Labs. They used to like have a telephone company, Bell Telephone. Okay. 1972. It's been around a long, long time. And obviously it's doing something right if we're still using it today, right? So, oops. Okay. Initially, it became the development language for Unix, okay? Unix came about because people were looking for a free or an open sourceware version of an operating system. Unix is free. Windows you pay for, usually when you buy your laptop, right? Mac OS you pay for, usually when you buy your laptop, okay? I don't even know anymore. You used to be able to buy laptops with no operating system on them. Put Unix on. Unix is. Many of today's are written in C or C++. It's mostly hardware independent. That's one of its niceties. Remember, we talked about you're going to need a different machine language for every single manufacturer. Okay. It's independent. Okay. So it is built for performance, for operating systems, embedded systems, real-time systems, communication. By the late 70s, we have what we have now as our C. Okay. In 1989, the 80s in that computer boom, we really started to go into standardizing some of these things. Okay. Because before that, it was kind of a free-for-all. Okay. I don't know if you know, but the Apple I was actually made by a group of like hobbyists out of like a wooden box. I'm trying to find a picture of it one time. They were like, hey guys, look at this, it's so cool. Okay. And so until the 80s, everyone was doing their own thing. So back in the 80s, they decided to create some of these organizations like American National Standards, or ANSI, I don't know if you use that word, or ISO, International Standards Organization. Okay. And they actually would approve a standardization across the board. So anyone using C is always going to use it in this, use this set of commands and files and things. Okay. Now, C has a standard library and open source libraries. We talked about that just a little bit about how we're not going to reinvent the wheel. It's already been done. We're going to go ahead and use it. Okay. We're going to get a little bit more into this, a little bit in the first half, a little bit more in the second half. Okay. So we have pieces called functions, which we'll learn about. And you can program all the functions you need in your C program. Okay. So not really understanding how the function works, you can create a function to do something and just call that function. Okay. But there are functions out there created by others that actually do a lot of the things that we need. Okay. And that's how we're going to use the C standard library. Okay. So 2 parts to programming. Learning the C language itself, the words, the syntax, how to make it work. Then the second part is learning how to use those functions in that standard library. Okay, where to find them, how to import them, how do we use them? Okay, so typically when we program, we'll see C standard library functions, open source. Does anyone know what open source means? Open source is basically free. People will put things together and put it out there for free use. Open source. Functions you create yourself and or functions that other people have created. Okay, we're calling this reuse. Sometimes they call it modularity, especially when we get to the project portion. Okay, one person is not going to do all the programming and one person is going to do the write-up. No, we're not playing that way. Okay, one individual might write the programming for what the user sees, and then maybe the partner will do all of the calculations and the computations behind it. But you're going to have to learn how to write code to talk to each other. Okay. You can also write your own code and save it and call it back at a later date. Okay. So these are some GitHub libraries. So when I originally pulled this slide from the book, it said there were, and this book is a 20, I'll put those links, I believe. No, I don't know. I don't remember. They were up there. They might be. So this book, I believe, is copyrighted. Let me see. Because I thought this was funny. So it is a 2022 copyright. Okay. When I pulled this slide, this number says 32,000. Okay. So I went to GitHub and I was like, okay, let's see what it is. And I clicked on that. They're over 50 now. Okay. It is ever growing. You can literally search on GitHub under this C topic and see everything out there that people are wanting to share in public for C. Okay. In addition, there's another list of popular C libraries. We'll look at some of those, like I said, more later. So, I believe this is the last little group. Other popular programming languages. BASIC. Has anyone heard of BASIC? That's what we learned in high school. That was one of the first things that was used to teach students how to program as BASIC, made in the 60s. C++, which we've talked about a little bit, based on C. It takes C into that object-oriented programming capabilities. Okay. So instead of just modifying C, they basically created a new language to piggyback on it to add that object-oriented so they didn't mess anything up. Okay. And again, that was in the 80s. Python, relatively new compared to some of the other ones. Okay, we're into the 90s now. It is one of the most popular programming languages. Okay, unfortunately, fortunately. I judge the North Carolina State Science and Engineering Fair, like the science fair. If I see another elementary school student with a Raspberry Pi and a Python, I may want to jump out the window. Okay. They all think they're the big old programmers with their Raspberry Pis and their Python doing it. Ew. And all they're really doing is they're using all those libraries that are out there. Okay. It was made specifically for education and scientific computing. Big difference from what we're going to do with C. Okay. Python is really good at doing numerical analysis with a lot of data. Okay, if you take any of the data science classes, you're either going to probably use R or Python. Okay. They're not very good with like the pretty and making it user friendly. Okay. Their purpose in life is not to make a pretty GUI with pretty buttons and colors and things. That's not their purpose. Their purpose is data crunching and education. Okay. Does that mean it's anything less? No, you can do a lot with that. Like I said, elementary school, Raspberry Pi, and Python. Okay. But it was kind of developed for that max number crunching. Java, which is where my heart lies, and that's where I was pretty much for 20 years. Okay, 1991. Originally, Java was one of the first programming languages to run regardless of operating. Okay, C, you can compile, but you do need to do a Windows compiler versus a Mac OS compile versus a Unix compiler. There are 3 different versions. Okay, Java, write once, run anywhere. Okay, where I was working at the time, we had some machines, which I don't even think they have anymore. We had Unix machines for computational abilities, and we had some Windows machines. And we needed our homegrown stuff to work anywhere. We use Java. Okay. C#. It's not C#, it's not C#, it's C#. It was actually created by Microsoft. Okay. And they use it as a object-oriented programming language based off of C as well. It is definitely more used in that HTML web-based interaction kind of cloud world than on, standalone applications that you might install onto your desktop. Okay. JavaScript, has anyone heard of that one? Yeah. Kind of taking Java and again, putting it into that web-based and that web page so that you can read it through Chrome and Edge and all those lovely stuff. Okay. All major browsers are supporting it. What about Swift? Has anyone heard of Swift? Swift is now what they're teaching in like the elementary schools. It's kind of like a drag and drop programming thing. I've seen a lot of Swift also when I do these science fair. And they'll be like, I want to do this. And so they drag and drop and then it like kind of creates code. It's kind of cool for like little bits. But that, Apple came up with that. It does have, it's a mishmash of C, Java, it's kind of a mishmash of other things. It is open source. Okay. So of course, education loves it because it's free. Right. Then we have R. Has anyone heard of R? Okay, R again is used for data crunching. It is open source, statistical applications, big data. Okay. You're looking at big data manipulation. Okay. Typical C programming environment. So typically we've got program develop environment, the language, and then the library. We can do a few different things. Okay, we have to go through these phases. Okay, we edit, pre-process, compile, link, load, execute. Okay. The nice thing about using an IDE or an integrated development environment, which is like that Dev C or the Visual Studio, it will do all of this with like one click. And we don't really have to worry about it as much. Okay. So first we create the program. Okay. So we edit the file in some kind of something. When we move on to doing that Unix, we're actually just going to compile it in like Notepad. Okay. You can do that. Phases 2 and 3, pre-processing and compiling. There are 2 different kinds of errors that you can have when you program. Number 1, we have a syntax error. Okay. A syntax error, your compiler is going to stop and it's going to yell at you. Okay. So for a syntax error, the compiler will halt. It will not finish compiling the program, and it's going to tell you there's something wrong. Most of the time, it gives you an error. Sometimes it gives you a line number. We're going to learn how to read those errors, okay? C standard does not specify the wording of the error. Sometimes the errors are good, sometimes not so good, okay? And you kind of learn what some of those errors mean, okay? Syntax errors are also called compile or compile time errors. It's at the compile stage, okay? The second, I'm gonna go back, I promise. I don't have the other one in there. The other one, the other type of error that you have is called a logic error, okay? That is a typo. Your program is gonna compile and it's gonna run and it's gonna look beautiful, but when you add 2 and 2, it's gonna output 6. You see the difference? There's something wrong in your computation that is giving you an incorrect answer, but the actual syntax is correct and it allowed it to compile. That's a runtime error versus a compile error, okay? The logic errors are a lot harder to find than the syntax, okay? Your compiler will give you the syntax errors. Logic errors, you gotta find yourself. Okay, so C programs use functions defined elsewhere. We already talked about standard libraries. So your object code produced by the compiler usually has holes in it, right? If I say I'm going to use the function in that book when I compile, there is a hole between what I wrote and what's in that book, right? You can use other code, but it creates holes. This linker is what's going to connect them. Okay, so the linker is going to go and find those libraries that you asked to be used and create a connection between your program and that standard library. Okay, that's the linker. Then it does a loading. Okay, it has to put it into memory, right? You can't run off the hard drive. Okay, it takes too long. So it transfers your executable from somewhere on a hard drive or permanent storage into the memory in order to run. Okay, it runs faster. Okay, it's also going to load any of those things that you use in that standard library. Okay, and then finally we execute it. Everything is all in memory, it's ready to go, and we say run and it's going to execute. Okay, again, when you use your IDE, it's going to do all of those things all for you. It's going to compile and run all together. Problems. Oh, there's my other errors. Errors, runtime errors, or execution time errors. That's the logic. We've got some fatal errors. Are you guys old enough to remember the blue screen of death? Okay, that's a fatal error. Dude, y'all, when you hit a fatal error, like it just stops. Doesn't tell you why. It just like no thank you, right? And just turns off. Those are pretty bad. Non-fatal, okay, 2 + 2 is 6. That's not fatal. It's not going to mess anything up. It's not going to screw anything up. It's just not right, okay? So standard input, standard outputs. Read some 9:30, right? Rock bottom. I don't think we're going to take that long. I hope not. And just so you know, the majority, the longest lectures are going to be like the first week or two. And then it's free. Anyway. Most of your programs, your whole reason for being is to do input and output, okay? So most will take input from your standard input stream, keyboard normally, right? Because what else could you use? Mouse, microphone, scanner, okay? Data is often output to your standard output. Typically, we're going to use our screen. Okay, we're not playing music, we're not printing anything. Again, it can also be put on disks, printers, other things. There's also a standard error stream, which is going to collect all of your errors and spit them all out to you at one time. Okay, so, oh, look at me. I'm good. Okay, so today we talked about the Git and the GitHub. Feels like it was forever ago. It's like an hour. Okay, there is that journal article linked in the resources that goes into Git and GitHub for more information. Just glance through it. Again, when she starts getting into some of the details of using it with R, she can really skip over that, okay? But she does really good with explaining basics. And then we went through basically chapter 1, which is just the introduction, okay? The biggest things to take away from that is some of those vocabulary words, okay? Volatile, right? Which means it's erased when you turn the computer off. When the electricity goes away, so does everything in memory, okay? Syntax error, logic error, things like that, Okay, I'm not gonna ask you what year did this like start. Okay, go ahead, okay? So Wednesday, right? We're not coming Tuesday. I will not be here. Okay, we're gonna look at our first C program. We're gonna look at Visual Studio Community Edition. We're gonna go into that chapter 2, which is just that basic program. Okay, this week's, you've got your labs, your GitHub setup, which you guys can go ahead and start doing now. I would wait on the first C programs until after Wednesday. Please make sure you sign up for a lab time so that I know what labs we need to cover. Okay, and if you cannot get a lab time that works with your schedule, let me know. Okay, I'm not trying to make this like difficult. Okay, so we want to make sure we communicate. I mean, I know probably half of you like pretty well. You guys know I'm not, again, I'm not trying to make it difficult. Come to me sooner than later with issues. For basketball, I actually know when your schedules are, but we'll communicate well. When you guys get in season, we'll start talking a little bit better, volleyball stuff. Because I know there's like some overnights and stuff like that. We'll work it out. So just let me know and just communicate. I'm big about communication, guys. Okay. No offense, but like if you tell me, hey, I have a game where I have practice. I don't know if I'm going to get my lab in by Friday because the lab and the homework right now I have due on Friday. I forgot to mention that. Okay. Here's the reason why. It's me, not you. I want to be able to review those labs over the weekend so that Monday morning's lecture is where it needs to be. Okay. So right now, all the homeworks and labs are due midnight Friday. Okay. So just make sure you're aware of that because I know a lot of people do Sunday. If I do Sunday, Monday's lecture might be way beyond y'all. I don't know what to go back and check in. Okay. So right now they're all due on Friday. If for some reason you can't make it on a Friday, please email me ahead of that Friday. Okay. No offense, but if you email me on Sunday and say, oh my gosh, I had this and I had that and I couldn't turn it on Friday, I'm like, too bad, so bad. Okay. If you tell me on Tuesday, hey, I think I can get it in by Friday, but do you think maybe I could have until Sunday because I have this, that, and the other? Sure, no problem. I'll work with you. Does that make sense? If it's after the due date, to me, it's an excuse. I have children. I know what it is. Okay. Questions, comments, concerns. I probably will put at least some of the key slides up there for you guys, like with the links and stuff, so that you guys can see that. But like I said, as far as this goes, don't get bogged down with like dates and years and people's names.